So force is the main factor that can cause a stress or a strain. All right, so that is why we have to do an overview of force before we start diving into stress and strain. Now, the first question we ask ourselves at this time is, what is a force? A force is a pull or a push. A force is a pull or a push. That is the simple definition for a force. And also you must note that when force is applied on a body, it can cause a change in the body's dimension or shape and motion of the body. So force is a very important factor when we are talking about stress and strain. So I'm saying that a force, when applied on a body, can cause change in dimension or motion of the body. Very, very important. And please, you must remember that the units for force is Newton. And don't forget that we can also use kilonewton, or we can use meganewton. Now, I want us to note again that no object or no material is perfectly rigid. All right. Now, when forces are applied to materials, they tend to have a change in dimension. All right. Some of which we might not see. All right, or some of which are not always obvious to the human eye, but those changes occur in the material. For example, a bridge. All right, now when the weight of vehicles drive on the bridge undergoes change in dimension. All right, but we might not be able to feel or see these changes taking place, but it do occur, and they are very minimum that we cannot see it. All right, so I'll be showing us at least 3 types of forces that affect materials. Okay, now the first one I'll be showing us here is called the tensile force. Now, before I explain the tensile force, I will show us a diagram. All right. So here is a force, and here is a force. All right, cool. Now, the first thing I want us to note from a tensile force is that a tensile force will produce tension. That's the first thing we must note, that a tensile force will produce tension. All right, first thing. Now, what is tension? Tension is a force that tends to stretch a material, as you can see below. So I'm saying that it's a force that tends to stretch a material, as shown below. All right. Now, because this force is stretching the material, it tends to what? To increase the length of the material. So we are saying that an effect of a tensile force acting on a material is that it increases the length of the material on which it is acting. So I'm saying that tensile force increases the length of the material on which it acts. Very, very important. So because the force is stretching the material, it tends to increase the length of that material. That is the effect of tensile force. I will give us 2 or 3 examples of an object that is undergoing tensile force. Let me give us 2 examples. Examples of materials that undergoes tensile force. The first one that comes to mind is a rubber band. A rubber band, when being stretched, undergoes tension. That is a very good example of tensile force acting on an object. Also, when a knot is being tightened, the bolts are under what? Tension. That's a good example. When a knot is being tightened, the bolts is under tension. So these are some examples of materials that undergoes tensile force. So the next type of mechanical force is compressive forces. Now let me show us a diagram to illustrate these points. Compressive forces. Here is the material, and here is a force acting on the material. Here is a next force acting on the material. All right. So here is the force, and here is the force. Now, for a compressive force, what we are seeing is that the force tends to compress or crush the material. But the first thing we must note is that compressive force will produce compression. All right, so it produces compression. That is a very important point to note, that compressive force will produce compression. Now, we are saying that from the diagram shown below, this force will tend to squeeze or crush the material. So it is a force that tends to squeeze or crush the material. That is a compressive force. Now, please note that because it is crushing or squeezing the material, our effect of compressive force is that compressive force will reduce the length of the material. So compressive force will decrease the length of the material on which it acts. So in writing, I'm saying that it decreases the length of the material on which it acts. All right, so that is for compressive force. It produces compression and it decreases the length of the material on which it acts. Again, I'll give us 2 examples of a compressive force. The first example that comes to mind is a pillar supporting a bridge. A pillar supporting a bridge. that pillar is in compression because the horizontal beam over the pillars are resting on the pillars, so it is compressing the pillars, so those pillars are under compression. Also, we have the sole of a shoe, or a sole of a shoe is in compression because as you walk on your shoe, you are applying pressure on your shoe. All right, that is why as time runs by, your shoe needs to be replaced because the sole must have eaten up. So the sole of a shoe undergoes compression. Okay, so moving on to the next type of mechanical force is called the shear force. The shear force. Here is another example of a force that can affect materials. It's called the shear force. I will show us a sketch or a diagram to explain this point. For example, here is the material. Here's the force, and here is a next force. All right, now let's explain what happens when a shear force is experienced. Now, a shear is a force that tends to slide one face of the material, as you can see on your screen, over an adjacent side. It tends, or I can say that shear is a force that tends to slide one face of the material over an adjacent face. All right, that is for a shear force. Now, I want us to note that the effect of shear force is this. A shear force can cause a material to bend, twist, or slide. It can even break the material. So we are saying that it can cause a material to bend, twist, or slide. That is the effect of a shear force acting on a material. It can cause the material to bend, to twist, or to slide. Now, I will give us two examples again of a shear force. I'll give us familiar examples. Now, one example that comes to mind for a shear force is a guarding shear. A guarding shear. All right, so a guarding shear can provide a shear force. A guarding shear can provide a shear force. Also, we have what we call a horizontal beam. A horizontal beam, all right, is subject to shear force. So these are two examples of shear force. Now, a beam is like a slab. I think you all know a slab. A slab, you can see a slab resting on the columns in your building. All right. So the slab or the horizontal beam is like a slab that is carrying the roof. So it's like the roof is resting on the horizontal beam. All right. While the pillars in your homes is carrying that slab. Now we are saying that that horizontal beam is subject to a shear force. So here are some examples of a shear force.